And we're live. Hello, everyone. Hi, Connor. Hi, Dan. How are you?
Hi, doing well. How are you?
Yeah, not
I'm
too
doing.
bad. Thank you. Sorry.
Oh yeah, no, it's. I'm doing great. It's rainy in Northern Ireland, especially in this converted attic, but all is well.
And it is snowstormy here in Canada.
It
How's the
is
late night in Vienna?
it is undecidedly somewhere between rainy and dry. Like, thankfully, now that I have a dog, I have to be careful about going out when it's raining because he doesn't like it. I'm not a fan either. So we need to plan around that a little bit more strategically.
Yeah, my dogs are the same. Whenever it's rainy out, they don't really want to do much.
Exactly. So, people who are joining, I'd love to hear from where in the world you're joining in. I'm super excited to be talking to you today. And can I just say, hey, it's Jen from Teach Gen Tech. Howdy, Jen. Hope you're doing good. Hi from currently sunny Denver, Colorado, US.
Howdy.
Fabulous. Good to have you here. We are currently waiting for one more to join us, but thought we'd just catch up a little bit. Can I just say on behalf of Suborbital, Happy New Year. This is our first time live, and it is just exciting to go into the new year. Cool stuff coming from us. Keep an eye on that. Oh, how'd you do that?
I clicked a button that I shouldn't have.
All fine, all fine. Yeah, excited to be kicking off 2023. We've got some cool stuff coming up this year. In fact, and keep an eye out. In fact, I'm just gonna. Do you know what? I'm just gonna throw out a quick cheeky link here. Come to our website, check out what we're doing. We've got some cool stuff coming out very, very soon. And today we're going to be doing a little bit of perspective around what it is that we're doing at Suborbital and what's in store, what do things look like, and yeah, all of that good stuff. And Oscar is here. Howdy, Oscar. How's it going?
Hello. How's it going?
All good here. Thank you so much for joining us. Oscar, I'm just catching you to catch you up briefly. We're just introducing what we're going to be doing today. And yeah, we're just going to be, talking about plugins, where they fit in. We got Flaky tuning in saying, hey, y'all, Tallinn, Estonia was nice and chilly snow until yesterday. Now it's slimy, gloomy, rainy. I'm not a fan of that. I'm sorry to hear that, Flaky. So, well, let's dive right in. Thank you all so much for joining me here. This is super cool to do. So I'm gonna go by super broad here and ask, well, what is Suborbital doing? Why? And why now? And feel free to take those as you like.
I'll take the first, and the two of you can fight over the other two parts. Suborbital is building a universal plugin and extensibility capability for any SaaS application. We mostly work with B2B SaaS companies to make their software platforms more extensible by allowing end users to write code that runs inside of their products. But the application of plugins is very broad, and we think that it's going to be a pretty big trend for the next couple of years. And we are capitalizing on a new technology, which is WebAssembly, to make that happen in a safe and manageable way. But yeah, the main premise is making software more flexible by allowing you to write software that goes inside other software.
Yeah, and I'll jump in on the why now. There's really been no better time than now for a number of reasons. We've seen an absolutely huge explosion in the number of user-defined functions that people want to write. How much are you hearing about AWS Lambda these days? It's sort of like a bread and butter technology at this point. Maybe a number of years ago, it was sort of like, oh yeah, this is a cool thing. Folks are using it, but now almost every single application, almost everyone they're using something like AWS Lambda. You're using Cloudflare Workers, you're using Netlify functions, you're using all these sort of different things. So users want to be able to write functions in their apps. So there's this thing that's really cool. But what's been the struggle all this time? It's arbitrary code execution, and that's incredibly difficult to pull off in a secure and safe way. But with the advent of WebAssembly, only WebAssembly being only around, Dan, how long is it now?
7 years?
7 years? Yeah.
I think 7 years since we were on by default in every major browser.
Yeah.
So for context, before joining Suborbital, I spent 8 years at Mozilla in the emerging technologies group where WebAssembly was conceived of. So I've got that history going back, and I think one of the why now parts that's really interesting is, it's arbitrary code execution. Like browsers are built for arbitrary code execution. That's like their core feature is running untrusted code safely. And so we are at a point where we have this capability that we can go in and steal from the browsers and put it inside any other application in the same way that Node took really great JavaScript runtimes out of the browser. We're taking a WASM runtime out of the browser because it gives us the mature, secure, and performant technology we need to run arbitrary code inside applications without having to resort to things like VM farms or whatever else.
I'd love to ask, if I may, for folks that are, curious about like this world of like user-defined functions and why. Oh, thank you so much for that banner. This is what we want this to be, an open conversation. So I'm going to use my abilities here and ask, like, what are the, perhaps a silly question, why do we want to have user-defined functions? What are their merits in today's ecosystem?
Yeah. So the way I like to think about this is developers have been able to do this within their own controlled systems forever, right? User-defined functions have existed inside of databases, for example, for probably longer than I've been alive. And so it's a paradigm that developers understand. I have a piece of software and it works 90% of how I want it to work, but there's maybe some edge case or there's maybe some special piece of functionality that I want to add that probably isn't broadly applicable to the rest of the users of that software, but nonetheless, I still want it to do the thing that I want it to do. And so within our systems that we control, like a database, this is something that we've been able to do and is a fairly well understood paradigm for a long time. But what hasn't been easily possible is for a developer to tightly customize a system that they do not control. So, especially a piece of SaaS software, which has basically become the norm lately. And the reason for that is really comes down to security. There are some adjacent problems like performance and all of that, but the biggest problem is security. Whereas like before in the 90s and early 2000s, the majority of software just ran locally on your computer. And so, to make it extensible wasn't that big of a deal, because if you wrote something malicious, the worst that it would probably do is affect your own computer. But when software started moving to the cloud and SaaS hosted, web applications kind of became the norm, we lost a lot of that capability, and we haven't been able to get it back because of that security problem of me as a malicious actor inserting malicious code into a hosted service that I do not own has a much larger ramification than a piece of software that was just running on my desktop. And WebAssembly, being born from a browser, which is its main job of is to execute untrusted code, is what's going to allow us to bring that back.
Yeah, I think there are two other kind of facets to that I find really interesting. Going back to the local software thing, you have to be a good developer to write code that's secure and exposed to the network online. Whereas if you're just running something local, you can be a novice safely because you're not worried about like, oh, I wrote this plugin for my media library or whatever else, but anyone on the internet can talk to it. Like, you better make sure that you've dotted all your I's and crossed your T's. If you were just doing that for like a Winamp plugin running on your Windows 98 computer, you have more freedom to experiment and you have more safety because like you're not exposed to the world. And we've lost a lot of that magic, and we've lost a lot of that kind of that on-ramp as we've moved software into the network. And you see companies like extensible SaaS isn't a new thing, right? I mean, the thing that a lot of people will be familiar with now is GitHub Actions, which is basically GitHub will give you a virtual machine with 16 gigs of RAM, 2 CPUs, tens of gigabytes of hard drive space to run whatever code you want. And they're able to do that because their parent company owns one of the largest cloud infrastructure providers in the world. So they can just throw unlimited VMs at the problem. And that's a really nice isolation boundary, but it's not accessible to smaller players. It's not maintainable by smaller players. And the idea of going to WebAssembly is that we can enable that same sort of experience of chuck untrusted code into an application, run it in a sandboxed way, let users do what they want to do. The platform itself hasn't built bespoke support for. And we can start quickly, we can run efficiently, because again, it's just like a browser. Browsers have to start up really fast. Every time you open a tab, they have to spin up a virtual machine to run JavaScript or whatever else, like a lightweight VM, to do that in a sandboxed way. And then when you close the tab, it all goes away. Well, all right, can we just do that same sort of model in the backend? Keep it all sandboxed, keep it fast, keep it efficient, and we can. And that's what I think is really exciting about what we're doing here, is that we're taking that technology from the browser and we're enabling these capabilities that used to be reserved for these really big players that we've lost in the move to SaaS.
Awesome. Thank you all so much. Got a question here from YMO. How long before you can replace Linux shells with something that can run arbitrary WASM scripts with no worries?
I guess it really depends on how much level of functionality you want. I mean, I see people doing this today. There are projects out there that folks are running WebAssembly and Kubernetes. So it really depends on sort of what level of maturity you're looking for in this sort of experience. Where I guess you're probably asking, when is this going to be really commonplace? When is it going to be really easy for me to do this? And honestly, not too long, maybe a year or two. Give it time for folks to get some more proper tooling in place, and you're going to see it more and more. But right now, there's plenty of languages you can use. There's plenty of it's very easy to get WebAssembly modules these days. Folks are compiling all sorts of things that we love to use across all the different ecosystems that we use all the time. So there's nothing really stopping you from doing it right now. But yeah, give it a year or two for commonplace tooling, and you'll be off to the races.
I think one of the big challenges with WebAssembly replacing or moving into places that are already dominated by other languages is how does it communicate with the outside world? Because being born in the browser, WebAssembly, as it was initially conceived, could kind of use JavaScript shims to reach out to web APIs, to the DOM API. So, you've got a browser, so you have network access, you have Canvas, you have WebGL, you can draw things on the screen, you can do computations, whatever else, you have the I/O. The problem is when you pull that out of the browser, you no longer have that supporting infrastructure to figure out how data gets in and out of your program. Node faced the same thing, where when Ryan Dahl created Node.js, all right, well, now he needs a standard library for JavaScript. And so now there is one, but it's not the only one. It's kind of a modular thing. Dino, which is an alternative JavaScript runtime, has a different standard library. So there are efforts in WebAssembly that now that we've kind of pulled WASM runtimes out of JavaScript runtimes, we're saying, all right, well, what is a file? What is a network socket? How should I make those available in a secure, sandboxable, sandbox by default, secure by default way? The majority of that effort is happening in a place, in an effort called WASI, the WebAssembly System Interface. But it's not done yet. It's in a snapshot that's pretty close to minimum viable, but like if you really want to replace arbitrary Linux programs with WebAssembly modules, you could do it right now, but you're probably going to be writing some of that bridging code in a bespoke way. And a year or two from now, there should be standard ways to do that.
Yeah, I do see it as a big potential win, though, because one of the unfortunate things that a lot of us do as developers is that we run shell scripts from the internet that we never even read, right? So installing some random tool from some random GitHub project that you thought was cool on Hacker News, you'll run the old curl pipe to sh. And that's honestly horrifying. The fact that we have kind of settled on that as the easiest way to install developer tools as an industry is frankly horrible. But WebAssembly could solve some of that scariness, and I envision it looking somewhat similar to how on an iPhone if something wants to access your photos, you have to say, yes, you can access my photos. If they want to access your contacts, you have to say, yes, you can access my contacts. I could see it being fairly similar, where you could go ahead and curl a WebAssembly module randomly off the internet and allow it to be executed. But then it would need permission to do anything because it is running inside of a sandbox. So I think it would be excellent if one day Linux shells were able to incorporate or even be based upon a sandboxing technology like WebAssembly, because it would be a net benefit for everyone's personal computer security. But like Dan said, it's probably a little ways away still while the standards get worked out.
And even going back to what Dan said, even like the WASI initiative, this is all very public and easy to see. So I encourage you all to go snooping around on GitHub. The WebAssembly organization has practically everything that you're looking for, where I find myself every week, and maybe I'm a special person, but I find myself every week going to github.com/webassembly/WASI and just taking a look at the spec, looking at development, seeing the new things that got merged in. One of their super exciting things that happened about what was that, maybe 12 weeks ago, was the merge of socket support. So you can write a web server using WebAssembly now, being able to accept a request on a socket. And what was super neat was, even the other day, for those of you who don't know, outside of Suborbital, I work on a programming language that compiles to WebAssembly. And someone said, hey, I just tried this out and I wrote a web server using the language. And that was, super cool to see. And we're starting to see more and more of this stuff happening. And obviously it's super early days for a lot of things like this, but we're going to see more and more of folks doing this. So, just give it a little bit of time, and this stuff really and truly is going to be commonplace.
Yeah, on the security link or security point, I passed a link to Ramón, who I think I'll throw up on the screen. Dan Goman, who has worked on WebAssembly really from the beginning, wrote a blog post last year called No Ghosts, talking about different ways to represent resources in a system, because WebAssembly is this opportunity to take everything that we've learned in software from the last several decades and think, hey, what if we weren't locked into this Unix view of file system ownership, and if you're running a process, that process can access anything that you can access because you're the person running it. And one of the ideas is we could redesign file system access to be based on resource handles that have capabilities, that have permissions attached to them. So if I don't want you to modify the file, I can modify a file. I can hand you a read-only handle to that file, things like that. And you're starting to see some of those ideas play out in the design of the WebAssembly system interface, which hopefully will lead us to a world that is a little more secure by default, a little more manageable by default.
That's fascinating. I'd love to bring up a couple questions that are coming into the chat.
Mm-hmm.
Got a broader one from Jen that I'd love to highlight briefly, saying, where do you think the industry is? Where do you see the industry going in the next 5 years? And what do you think would be the bigger challenges to get there? And I would assume that this is related to specifically to using WebAssembly for plugins, but also plugin extensible software in general.
Yeah, absolutely. I'll also give the WebAssembly answer as well, because the WebAssembly industry, I think, also has
Awesome.
An answer there. In terms of WebAssembly, I actually see WebAssembly becoming an implementation detail for a lot of things. It will very likely fall into the background for most people, in the same way that POSIX is, generally something that most people don't actively need to think about on a regular basis.
Sorry, what's POSIX? Sorry.
POSIX, it's the standard system interface for Linux-based systems.
Awesome.
And the fact that you needed to ask that question, I think, will probably be the same for WebAssembly, and WASI in a couple of years, right? It shouldn't be something that every developer needs to care about. It should be an implementation detail, and the biggest barrier to getting to that point will probably be tooling, and having it be universally supported in all of the various programming languages and environments like Docker and cloud environments like Kubernetes and AWS. And then in terms of the plugins answer to the 5-year question is, I see developers being able to deploy code into SaaS applications that they use just as easily as they deploy code into AWS or Cloudflare workers. I do think it will become a table stakes feature for a lot of SaaS applications, and being able to program these applications, so to speak, is going to become so commonplace that you'll be annoyed if it doesn't have such a capability.
I think from where I'm sitting, the WebAssembly hype needs to die. It feels like server-side WebAssembly is really overheated. People coming in saying, this will solve all of your runtime problems. This will make your software faster. It'll make it more secure. It'll make it more nimble. And it can do some of those things, but I don't think it's uniquely capable of that. Where WebAssembly is uniquely capable is, again, that taking all of the hard-won experience of building a secure runtime for untrusted code on the web and making that efficient and portable. You'll always get faster performance running code natively. But WebAssembly can be damn fast. It can be fast enough with all that extra sandboxing, whatever else. And so I'm more interested in, right tool for the right job, right? There are places where you want, even today with the dominance of containers and Docker, there are still places where you want a full-fledged VM. There are places where you want genuine bare metal. And that will still exist. We're adding another option to the table in the same way that in the browser, the Genesis WebAssembly was looking at it and saying, we have JavaScript, and JavaScript's a great language, but it's only one language. How do we bring more languages in? How do we replace the browsers that used to have native plugins, like used to run Java applets or Flash or whatever else inside your browser? And that was a big security issue. But we couldn't just say, okay, throw out all of the Java and all the C++ and everything else you wrote. Because companies, Adobe had decades of investment into their PDF library. So we had to provide a way for those things to move to the web. And that was the idea of WebAssembly, provide a generic low-level target that can be universal and can go everywhere. And that's what I'm excited about. It also feels like the industry in 5 years, it feels like we're at the start of some pretty serious pushback against incidental complexity. I'm seeing a lot more people rejecting Kubernetes, or at least being willing to admit that it's not a panacea than I was seeing 5 years ago. And that's kind of exciting. And, you'll see Hacker News comments about, hey, I could just run this on a single Linux server in my basement. It would be fine. And I don't think that discourse would have happened a few years ago. So I'm hoping that we're getting to an era where we can start trimming down the complexity. And hey, if we can just run arbitrary code inside our software, we don't have to worry about setting up like all these webhooks and all these other API endpoints. We can just say, here is the point where the plugin runs. It worked for Winamp. It worked for desktop software. Let's make it work for SaaS software.
Yeah. And hey, I wouldn't be surprised if one day, Apple or Intel shipped a little coprocessor that can directly interpret WebAssembly. Stuff like that is certainly possible, especially if it becomes, a fully well accepted technology. There's no reason why chip makers and the rise of RISC-V type systems, there's no reason why WebAssembly couldn't become quite literally a hardware instruction set one day. There's obviously, it's more complicated than that, but I think it's a certain possibility.
I have to admit that is something I had not considered as a possibility, especially as the ubiquity, of it grows. Wymo says, I bet some startup is working on that hardware today. It's likely.
Yeah. I've seen several IoT companies interested in using WebAssembly as their IoT runtime because it is capable of running on low power, resource constrained devices, and it has the security benefits that you want out of a device that is, quite literally maybe even watching you, with a camera.
You can easily find those folks. The runtime that most of those folks are using is a runtime called Whammer, or the WebAssembly micro runtime. So if you snoop around that repository and see what folks are asking questions, you'll learn a lot of interesting things about what players are already in this space.
Yeah. And it opens the question, like, should maybe one day will I be able to, add plugins to my home security camera or the water sensor that's, stopping my basement from flooding? Like, those kinds of things could potentially be targets for extensibility one day as well, if we all, choose WebAssembly as a technology that is suited for the job.
And that is what I think made it all sort of fall into place for me, is this sort of comparison of like extending your software, your SaaS software, so similarly to how we've been extending our offline software for ages now, and being able to, for example, as YMO says, add code to my coffee mug. You know, so too being able, just like we've been doing in places like our browser, like the browser for me is like the biggest one when it comes to this, and how the history of browser plugins has sort of like informed how it is that we are looking into shaping the future of extensible software. With WebAssembly as a backing technology, you just sort of say like, okay, this is your sandbox, this is where you can go and play, so to speak, dictating how that code gets written, and really letting developers just worry about code. Which for me, because I spend a lot of time working with folks who are looking into building up a portfolio online, or like working on their first steps into coding. And when you want to make a website nowadays, it's not so much, let me just grab some HTML, CSS, JavaScript, throw that up on the web. I mean, you can, but that's not what most people are doing, right? They've got this whole myriad of stuff to worry about. I mean, not to mention the infrastructure that goes behind that, but really giving a developer the ability to say, hey, here you go, this is what you can do, run with it, we'll take care of the rest. I think that's pretty compelling for folks. And so I think that plays very nicely into what we're trying to do here at Suborbital as well, unless I'm mistaken.
Well, I mean, look at WordPress, right? WordPress dominates an enormous portion of the web, and it's as ubiquitous as it is, not because it's necessarily like covering all the use cases, but because it had a plugin API that let people adapt it to do whatever they needed it to, and it provided enough of a core to go everywhere. The problem is it didn't have the sandboxing abilities that we now have come to realize are necessary if you're going to be putting things out on the live internet. And so WordPress got a pretty rough reputation for security, especially around third-party plugins. But you can't deny the power and the impact that extensibility had on that platform, being able to adapt itself to fit so many different needs, from content management to, I mean, people run businesses off of it, whatever. Let's get that same power safely.
I want to highlight what YMO said here about, I see Wasm being adopted by games companies next for doing mods. Not sure if you can tell, but I am from the Doom mods era. I do love me some Doom mods, good times. Mm-hmm. And this is something you're seeing quite often. Like the one that keeps coming back to me is Microsoft Flight Simulator, letting you write mods using WebAssembly, essentially letting you write, your mods in your own code, a quick Python script, a quick, a quick Ruby script, some stuff like this. I think it's so compelling.
Yep.
Yeah, it blew my mind when I realized that Flight Simulator was already using WebAssembly for plugins. It makes so much sense. I had no idea it was in production, but it is.
And unless I'm mistaken, this is sort of, allowing folks to, for example, add their own. I've never used my Flight Simulator, but my computer's not powerful enough. But essentially letting you do things like, add your own planes, add your own like levels, physics engine stuff in your own program, in your programming language of choice. That is, and still operating within the constraints of what Flight Simulator lets you do. So you can download, for example, a plugin. I mean, I don't know about the rest of y'all, but I've been in situations where I've downloaded plugins that turned out to not do exactly what they say they did, but not have to worry about, say, malware, for example.
Yep. It's a pretty different way both to think about how software could be useful, but also it's a different way of thinking about the constraints of these kinds of plugins. Like there's obviously, you're not going to get as much freedom as you may have back in the desktop software era. But, I think what we found multiple times over the last couple of years is that, developers especially thrive under constraints. And while, it would be cool to say, hey, if Flight Simulator, give me a full Node.js runtime and let me go wild and, do whatever I want. But I think people find creative ways to do awesome stuff, even when they have, a constrained environment. Like, hey, here's the definition of a plane in Flight Simulator. Go nuts! Like, somebody's going to go and implement the Death Star, even though it's not technically a plane, right? Like, there's a ton of interesting things that can happen, even given the security, mindset and capabilities of WebAssembly.
And the thing I find interesting that we haven't talked about is right at the very top of the Flight Simulator docs. In order to provide both security and portability, we're moving away from DLLs in favor of WebAssembly modules. And we haven't talked about the portability aspect of WebAssembly much. Should we?
Please,
Sure.
I'd say we definitely should.
So when we say portability, we're talking really about architecture portability. Like, you might have heard things about portable C or portable other languages. And what that usually refers to is source level portability, right? Like, if I write something in plain C, I can probably compile it to run on any CPU architecture out there. The problem is I have to know what architecture I'm targeting ahead of time. And again, going back to WebAssembly's legacy of coming from the web, you don't know what CPU the web is going to run on. 2 years ago, Apple switched all of their computers, all their laptops from Intel to ARM architecture. And so if we had been relying on it, like in the Flight Simulator case, DLLs, natively compiled to target architecture, so CPU and an operating system, suddenly those wouldn't work anymore. And that's not good enough for the web, because the web has to be universal. The web has to be open standard space, and it has to go everywhere. What WebAssembly does, and this for people of a certain vintage will be like, I've heard write once, run anywhere before. It invites comparisons to Java's marketing tagline. What WebAssembly does is it recognizes that, all right, we don't know what CPU architectures are going to be out there, but we can look at existing ones like Intel, ARM, MIPS, and define a kind of least common denominator set of operations. So in contrast to JVM bytecode from the Java ecosystem or .NET CLR bytecode, WebAssembly doesn't try to have high-level objects or garbage collection or things like that kind of as part of the core language. It's really just like, if you were building the least common denominator CPU, here are the instructions you'd have. So WebAssembly has 5 data types. It has 64 and 32-bit floats and ints, and it has a 128-bit long numeric type. And it can do math, and that's it. And on top of that, you can layer function calls and memory access and things like that and provide access to APIs. But by starting at that really minimal level, you still get all the pre-compilation benefits, because your compiler can treat targeting WebAssembly just like targeting any other CPU architecture. And then when your target runtime receives the WebAssembly, it can translate it very, very quickly into native machine code. And this gives you 2 things. One, because the web is going to go everywhere, these WebAssembly runtimes are going to go everywhere. You're going to have the ability to run WASM anywhere that you're going to run code. 2, because we're in control, or that runtime is in control of that native code generation process, it can enforce certain security constraints. So it's not trying to execute the code that's given directly. It's trying to say, all right, convert this kind of abstract instruction set into safe native code, and you get a certain degree of checks there, which is really nice. And that kind of lets everything go everywhere. It lets WebAssembly take code wherever the web goes, which is going to be universal.
And Dan, I'll just also throw in is, don't you worry, garbage collection is indeed coming to WebAssembly, and things will get far more complicated with way more types. Actually, I can't remember how many types that proposal added, but it was quite a number. But it will grow and get some higher level constructs that all the runtimes will be able to represent on the various platforms. But that's the thing, these aren't things that are getting added to WebAssembly haphazardly or just thinking about one particular system in mind. It's thinking about all the different architectures it actually wants to be able to run on, going through committee, making sure all the different players in the space can actually implement this stuff and can do so, efficiently. And it makes sense for, language and runtime implementers to actually, use. And I think that sort of approach to it is what's so different this time around when you think about it from why not just use Java sort of perspective.
Yeah, and there's, I mean, to that point, like, yes, other features are coming to the core WebAssembly language. It's not done. But in the same way that, like, CPUs have different extensible instruction sets. So like some CPUs may have special operations for vectors or other things. And we have experience in the industry of dealing with that. And WebAssembly will learn from that as well. So as we gain these capabilities, we're not going to lose the universality or the portability that WebAssembly gives us.
So we do have a question from Flaky, and I don't want to be rude, but I do have like a question to what you're saying. We have, and I hear a lot about this sort of near native architecture. Should we be worried about this sort of latency that's created by having a runtime on top of it, or is the near native speed near native?
Oh yeah, I mean, Dan, if I can jump in on that.
Please.
Yeah, no, absolutely. It truly, really and truly is near native. And so one technology that's used in a lot of different systems is just-in-time compilation. So if you've ever heard like jitting compilers or something like that, it's this process where when your WebAssembly code is being executed, maybe the first time it's executed, maybe the second time, the runtimes can be smart enough to say, actually, you know what? This is important code that I can run and can instantly go to real machine instructions just in time in the moment, so it can run at native speed. So you can even go from near native speed to full native speed running in WebAssembly and still keep the same sandboxing properties. And that's one of the things that's super neat about WebAssembly. And we sort of talked about this with Microsoft Flight Simulator, but they don't even do just-in-time compilation. They just say, oh, you know what? We're just going to compile it completely ahead of time, so it's completely ready to go, and it will run at native speed. However, we get the safety guarantees of WebAssembly. So in terms of like speed, it will certainly be fast enough. I think we should start getting worried when folks are starting to run WebAssembly in WebAssembly, and I think that'll end up happening before we know it.
Someone's gonna try.
I feel like folks have already.
I think the WASM 3 folks have already done that. I know for a fact that you can compile WASM 3 within WASM 3. So I wouldn't be surprised if you could also run WASM 3 within WASM 3.
Very likely. No, thank you. That's super handy and good to know. Let's bring in Flacky's question, who's asking, what tools exist in WebAssembly that help people avoid a nasty surprise from a rogue WASM module or plugin?
Yeah, so this is kind of lends into one of the topics that we wanted to cover today, which is the tightrope that you need to walk between keeping a plugin system like ours secure versus giving developers the capabilities and the APIs that they need to build useful plugins. And so WebAssembly at its core and the sandboxing model that it's designed around is what they call a deny by default sandbox. And what this means is that the code running inside of a WebAssembly runtime can only access the resources that it is explicitly given, usually ahead of time. And what this means is that it can't read a file unless it has been explicitly granted access to that file. It can't open a network connection unless it has been given that network connection. It can't just reach out and create or grab a network connection unless it has been explicitly given to it. And so this differs from something like a Docker container, where it's generally open by default and you can optionally lock it down to be more secure. WebAssembly takes that opposite approach, which is it comes from the genesis of being in the web browser, where that's kind of how web browsers or have always thought about running code. And so the tightrope that we walk as a company providing a plugin platform based on WebAssembly is, okay, how do we take advantage of this deny by default sandbox to keep our customers and our infrastructure safe while still allowing plugin developers to do interesting stuff? And we have solved this problem in a particular way that we call the capability system. Other companies have done different variations of this, and WASI itself is effectively an implementation of this as well, where we have granted our WebAssembly runtime certain capabilities. For example, an HTTP client, so the ability for a plugin to make an HTTP request out to an external endpoint and retrieve the response. And the way that this happens is that when our WebAssembly runtime comes online, when that plugin is executed, our host software passes in an API, a function called fetch URL, and that function gets added to the global function table of the WebAssembly module, so it is made available to the code running inside that plugin. And so whenever one of the plugins wants to make an HTTP request, it calls the function that we have passed into the sandbox. And then the code that we've written on the outside is able to take a look at that request to make an HTTP call, and then we can further evaluate that based on the rules that we have configured to determine whether or not that HTTP request is allowed to proceed. So for example, if a plugin tries to make a request to my internal Kubernetes control plane, trying to request all of the pods that are running in my infrastructure, we can very easily say, no, that's not allowed. But you are allowed to make a HTTP request to say the Stripe API or the Google API or whatever, and we can do this selective filtering kind of at two different levels, right? First, just in granting the ability to even know about an HTTP client in the first place. And then once that HTTP client is used, then further filter it based on the specific request that is being made and evaluate it based on the rules that we've set for the security of our infrastructure.
So Connor kind of talked about it at the API level, that WebAssembly modules can only do things with the tools we place into their sandbox in the same way that JavaScript can only do math unless you give it access to like the DOM APIs in a browser or whatever else. There are also designs in WebAssembly itself as an executable format that try to make it safer than native executables. So you can't jump to, so WebAssembly has structured control flow, so you can't jump to a random point in memory and start executing data that was supposed to be like data, not code. And so there are things being built in, again, both at the API level where we control like what's in the sandbox, what capabilities does it have, how are those implemented. And there are also things in WebAssembly itself that mean that certain types of exploits just aren't possible. I know, Connor, you've actually implemented a language in WASM if you want to talk more about, or not Connor, Oscar, if you want to talk more about that.
I was going to say, not my area.
Yeah, it's really interesting, especially from like a language author standpoint. In some regards, coming to WebAssembly, you do have to throw out much of what you know about assembly language, because you might be more used to, hey, yeah, I can just jump to this random point and start executing here. Or if I want to inspect every single live object on the stack, I can. And that's a thing that isn't possible in WebAssembly. I can't just go and look at all the stack frames that currently are live. That's not something that's available for me to do. So you have to think about generating code in a very new and different way. Now, it's not saying that this is completely novel to WebAssembly. These concepts have been explored before, but not sort of in something that has gotten so mainstream. So that's sort of what makes it really interesting. But I can tell you, first off that it would be very difficult. Like if I think of like x86 code, I can think of a number of ways to write crazy exploits. But within WebAssembly, I can't even access a memory that wasn't explicitly granted to me. So I can look at my memory that I might have created, and if you give me a memory, I can look at it. I can't execute any code in it. If there are functions or maybe even closures that exist, it's like I can't do anything with them. I can maybe look at some data, but that's about it. And these sort of protections really change the game in terms of safety, because it means that, even within like those WebAssembly plugins, if you have them interacting with each other, they're not going to be able to, screw with each other in the same way that you could with other, types of assembly language. So generally, WebAssembly has been thought from the ground up, from a point of safety and really being able to be executed in just safe manners where code is completely sandboxed from each other, even down to that level, right? There aren't escape hatches that allow you to get crazy with it until, of course, we start executing WebAssembly and WebAssembly. But we'll get to that when we get to it.
Yeah, what else you're saying about like getting to jumping to different points in memory and executing code there, that was one of the big hurdles for the Go programming language to come to WebAssembly. There's an issue filed back in 2017 saying our current conclusion is that there's no efficient way to implement set jump and long jump within WebAssembly currently. And so, you can make things work, but WebAssembly has a different execution model than what you might expect if you're compiling something to an ELF or Mach-O executable on Linux or Mac OS, because we're trying to separate out memory from functions semantically. So you're not having these like, oh, suddenly execution is somewhere I wasn't expecting it to be. The downside is if you rely on being able to go and run code from random points of memory, you have to find a different way to do what you're doing.
And even to add on one small thing that I think folks might understand really well, one thing that WebAssembly did is sort of like what TypeScript did to JavaScript, where it's like, hey, JavaScript's a little bit of a mess where nothing is well typed. We don't know what values are coming in. We're just sort of hoping everything works out. But WebAssembly is actually a typed assembly language. So when your compiler generates WebAssembly code, it's all statically typed. So you're not going to end up with invalid code that would not be able to execute. And in fact, within these types, you can even tell when a particular piece of WebAssembly code would fail or stop executing in certain scenarios. And that's something that's actually kind of unique that we get out of WebAssembly. And it's due to these unique typing properties. And even like to the point of like, set jump and long jump, even for short jumps, like implementing a switch statement where you might want to just jump to a particular branch, even that, there's a special construct in WebAssembly for, hey, I need to do this exact thing in this really small scoped area, and it can only exist within a single function. You can't get crazy with it. So they really make sure that you're going to do things in a safe manner and in the way that they want you to, which I think is really neat and I haven't seen before in any other assembly language.
I just realized that what you said there really unlocked something for me, which is that, I started out like my first job was making macOS software with Objective-C, and then I switched over to Swift, where I really felt like I was constrained by the mandates that Swift makes on, type safety and like, null safety. That's it. Thinking about the fact that this is now at a architecture level is kind of weird and mind-blowing, and I dig it.
And it's not necessarily, and at first you might feel that you're a little bit restricted, but then after time you realize actually it's forcing me to write much better software.
Yeah, right, exactly. Exactly, kind of like saving you from yourself as a programmer.
Absolutely, 'cause I would write that jump if I could. I really would.
Yeah.
But they're really telling me, hey, no, don't do it. Really think about your problems and think about what you're trying to accomplish. And I've come up with a better solution almost every time.
Yeah. Yeah, no, that's fascinating. Thank you. Got another question here from YMO. Can you touch on how garbage collected languages target WASM today? What's different between, say, Rust and Go, for example?
Yeah. So generally, garbage collected languages targeting WebAssembly just re-implement the garbage collector within the WebAssembly sandbox. So in your WebAssembly module, you're accessing a linear memory, and so you just write some code that manages that memory. Languages like Rust are, a little bit more unique because they try to do a lot with managing lifetimes of objects and being able to collect them a certain way. So Rust actually doesn't necessarily have as hard of a time with this because there is sort of like no big global GC that's just hungry and waiting to eat all your objects. They're making sure they're doing it at appropriate predictable times, which is really neat for Rust. I do believe this was an issue for Go, and I think that was one of the main driving factors behind the TinyGo language was, hey, actually, we need to figure out something about the memory model. The Go GC is actually pretty big, and fitting that into WebAssembly module is not really feasible. And so they had to come up with something different. But sort of touching back on, GC coming to WebAssembly, conveniently in browsers, browsers already have very strong, powerful garbage collection engines, right? So we don't actually need to re-implement garbage collection in every single language if there are constructs available to us in WebAssembly. So for me, it's like a language person, I am very excited for the day that WebAssembly GC is commonplace. I will happily delete the garbage collector from my language. It will be gone forever, and I will allow runtimes to do that for me in whatever way they can. And what's even neater about that is for thinking about us in terms of plugins, where typically a lot of the plugins that we write are very short-lived. Meaning you probably don't actually care about garbage collection, where, and this is one of my favorite phrases, sometimes the best garbage collector is os.exit, just leaving the program. You don't need to worry about cleaning thing up if your program is pretty short-lived. And in the case of plugins, we could actually get back a lot of speed by just not worrying about garbage collection at all. And this is something that's going to be possible in WebAssembly when we do have the ability to just turn it off for whatever language we feel like, right? So there's a lot of really exciting developments and a lot of really interesting things that we can do. Even, just thinking about how this all plays up to plugins. You might not think about those small little instructions mattering in terms of these bigger picture ideas that we have, but they really do. And that's sort of what's neat about following everything here.
Yeah, at a past gig, we gained significant speed ups on process restart by disabling Python's garbage collector. It's like, no, we're throwing all this out anyways. Don't even try. So yeah, if you're doing short-lived things like plugins, which is what we're doing at Suborbital, yeah, those are going to execute. They're going to exit. We don't need to worry about cleaning up too much.
Awesome. Thank you both. And thank you all for asking these questions. This has been a really cool conversation for me because I kind of want to like end this on perhaps a silly question, but bear with me, please. We've been talking about, plugins and WebAssembly and sort of our vision as Suborbital as being able to give people the power to give their customers the ability to write their own code that runs against it. So given that this is something that we're hoping becomes more prevalent in SaaS out there, does any of you have like just one SaaS app out there that you wish you could write code against? And perhaps a use case for that. I'm throwing it out there. Like, feel free to be like, Ramon, that's a silly question.
Yeah, for me, it would be Google Calendar. Like, I really wish that I could, write code that runs anytime somebody invites me to a meeting. Would it be an auto decline bot? Maybe, but I think that would be a really good contender for a plugin like this. Is that we've seen a lot of stuff in the last couple of years, like Calendly and SavvyCal of like trying to automate the calendar experience a little bit more, but being able to do things like writing my own algorithm for finding meeting times with my team, because like I personally try to reserve Wednesdays as my day to get focused work done. And so if I could write my own algorithm that says, hey, find a time to meet with Ramon and Oscar and Dan, but omit Wednesdays and omit Friday afternoons because nobody wants to go to a meeting on Friday afternoon, like just simple stuff like that. I think that would be a really good candidate.
Yeah, I think my brain really jumps to, what don't I want to add plugins to? No, but seriously, because it's the thing is you don't necessarily, if you just ask the question blanket, you might not realize it, but sort of in your everyday life as you're using particular applications, you realize, oh, it would be great if every time you have a feeling, oh, if this app were just a little bit different, almost every single time you have that feeling, that's where plugins are applicable. Where one of the ones that I just thought of was one of my favorite apps, Dark Sky, rest in peace, Dark Sky, you were great. But in this application, right, it would be fantastic if I could just add just little touch points where I want it to, where, when I have that hyper local data that tells me, hey, it's about to rain in 3 minutes, that's great to know. But it would be fantastic if maybe when I am about to go out to my car or something like that, usually I open up that app on my phone. If I could integrate those two things together, it says, hey, Oscar, don't be stupid. Just grab your umbrella right now, right? Like that would be something that would be fantastic, right? I don't necessarily want to rely on special notifications for that. I want to maybe like hook up like a little light by my door that tells me to do it. If the red light is on, grab your umbrella, right? Like that would be fantastic. And it's all these like little tiny experiences that would just make my life better. And so I think that's how I encourage everyone to think about it is anything you want to be slightly different that you could just tweak just a little bit. These plugins don't have to be huge, right? Like my favorite plugins are those 1 or 2 liners that, change my life, right? That's what I'm really about.
I mean, I'm gonna be maybe a little more boring and say like, almost everything I want to do something. But the damnedest thing is most of the software I use, I could do that if I was willing to set up a server to receive webhooks and talk to their APIs. But like, one, I ain't gonna learn your API. Two, I got kids. Like, I ain't got time. I got kids in a day job. I ain't got time to go and be a sysadmin for a hobby anymore. Like, what I want to do is give you 3 lines of code and you just run it for me in the app. Please, just make it happen. And I want to do that with everything. Like, everything. Slack, Notion, Google Calendar. The capabilities are there. The software is extensible, but it makes me jump through all these hoops and pay $5 a month to run a VPS somewhere. And like, I ain't got time for that.
That's super
just
fair.
even more ideas are flowing through my head. Because you mentioned Slack, and I was like, the number of integrations I'd love to have in like my community Discord would be fantastic. You know, nothing against their auto mod, but oh man, let me code my own auto mod and I don't have to manage like the servers. That would be absolutely fantastic, because I have very, very specific rules that I want to necessarily auto ban someone for, right? That I can't necessarily use like an auto mod tool for. But it would be a very simple, you know, even 1 line of code to get these things done. So I am looking forward to the future where, like Connor says, you know, plugins are table stakes, where every app has the ability for you to just slot in whatever you need, right? And it's beneficial for everyone. It's super cheap for folks to execute WebAssembly modules. I mean, it's not like it's a huge burden. They're tiny, they're small, right? It's not like it's going to cost, you know, these companies, you know, tons and tons of money to do this for the value that, you know, folks are going to get out of it. It's absurd, right? So I'm very much so looking for the day that we make it there, and I think it's on the horizon.
Love it. Thank you all so much. And I think we got some of the folks in the chat already also fired up about it. We got Flocky saying WASM in Excel. YMO saying, yeah, so all SaaS, Twitter, my window manager, my phone, my car, being able to reuse a module someone else wrote to automate my email or my SaaS. Yeah, no, this is, I'm glad that folks are getting enthusiastic. I see a marketplace for all these WASM modules. Yeah, and that's exactly it. No, I'm very, very happy to have had all of you on today, and you know, being able to pick your brain about this and sharing these insights, because I think they're fascinating and exciting for what's to come. So I will say thank you to all folks. If you're interested in signing up for what we're doing here at Suborbital, please head on over to suborbital.dev. You can sign up for our public beta. Keep an eye out for that. And yeah, thank you all once again so much. Appreciate you all taking the time to talk to me here live. And yeah, have a good one, everybody. Thank you all for joining the chat and asking your questions.
Thanks, Ramon.
Bye, all.
Bye.